Hi there, and welcome to this video on multiplying and dividing rational expressions. And you might hear my cat in the background, possibly. All right, give this video a thumbs up if you find it helpful. Subscribe to the channel for more math help. Please engage by dropping a comment, a question, or a thank you. And be sure to check out the practice set for this lesson. Because of the nature of these problems, there are just 4 problems. I think that I just finished recording the practice set video, and it is about 25 minutes long with just the 4 problems. So, but I want to put a disclaimer on this right at the outset. Number 3 has a typo. So if you're working on the practice set and you're coming to the practice set from here, now you have a heads up. I copied what should have been a 3 as a 15, and then chaos ensues in the practice video. So my apologies for that, but I'm doing my best to give you a heads up that you might want to skip number 3, or just recognize if 3 gets kind of like messy or it doesn't seem like it simplifies right, it probably means you did the problem correctly. And when I go over it, I obviously kind of catch the mistake and have to back up a bit, and I do finish the problem as written, even though it doesn't simplify the way we would like. Okay, so that's your heads up. So I wanted to start off by just kind of doing a refresher on how do we multiply and divide fractions. And this is not intended to be a lesson on multiplying and dividing fractions. We are just going to go over the kind of traditional algorithm for how we carry out these operations. That will probably be a video in the future. In fact, I think I've got some videos on the channel that kind of go through the whys of this is why we multiply them this way, but that is not the scope of this particular video. So the scope of this video is how do we multiply and divide fractions? Well, when we multiply fractions, it's the easiest operation we can do. We just multiply straight across. And so A over B times C over D is just AC over BD. And it all ends up in one gigantic fraction. So if you had something like 2/3 times 1/5, that would be 2 times 1 over 3 times 5, which is 2. I said 5. I wrote 15. I wrote the answer. That's how you end up making typos. 3 times 5, which is 15. So 2/3 times 1/5 is 2/15. And there are some cool ways to show that is what that is, but again, not in the scope of this particular video. So that's how you multiply fractions. Now, dividing fractions is similar. Division is multiplication by the reciprocal. And so what we would do here is we would take the A over B, and instead of dividing it by C over D, we would multiply it by D over C. We would take the reciprocal. And so division can be just rewritten as a multiplication problem. You just take the reciprocal of the thing that you were dividing by. And so this becomes AD over BC. So if you were to do 2/3 divided by 1/5, that would be 2/3 times 5 over 1, which would be 2 times 5 over 3 times 1, or 10/3. Okay. So that's how that would work. Now, that is pretty much all there is to this. This is one of those lessons where you almost don't need to teach it if you understand the ground level. If you know how to operate with fractions and you also know how to factor, then you can do these. It's not really its own lesson, but a refresher is good. Now, this leads to something that is sometimes called cross-canceling. And so essentially what we can do is we can multiply and then cancel, or we can cancel and then multiply. This is because multiplication and division have the same rank in your order of operations. So let me just see if I can illustrate this for you. So if you had 2/3 times 4/2, okay, you could multiply and then cancel. So you could do 2 times 4 is 8. and then 3 times 2 is 6. And then you would recognize, oh, like both of these can be divided by 2. And so that simplifies to 4/3. Okay. And that works just fine. Or you can cancel and then multiply. So if you look at what we did there, we essentially multiplied by 2. Okay, so we did the 2 times 4, and then we did the 2 times 3. So we multiplied by 2, and then we immediately divided by 2. Okay, like we went and undid the multiplication that we just did. And so if you're looking at that and thinking, I feel like you did more steps there than you needed to do, that would be correct. So if we multiply by 2 and then immediately divide by 2 to simplify it, we could actually get there faster if we never bothered to multiply by the 2 to begin with. And so cross canceling is this. If you've got something in the numerator and something in the denominator, you can go ahead and cancel those out as common factors before you ever do the multiplication. And of course, 2 divided by 2 is 1. So you end up with like 1/1. And then you would multiply those. And then you have like the 4 in the numerator and the 3 in the denominator. And we just saved ourselves like the nuisance of multiplying and then dividing. Sometimes this is called cross canceling, where you're canceling anything anywhere in the numerators of any of the fractions being multiplied with any denominator. Okay, as long as it's in a numerator and denominator, it doesn't matter which fraction it's in, because once you multiply them, they're all going to end up together anyway. I never really thought of this as being something like separate or different. It's just leveraging your order of operations, so you're not doing an unnecessary operation by multiplying and then immediately dividing. But you do whatever is easiest for you, and what's really critical is that you're doing what makes sense to you. So you want to do what makes sense to you, not like what seems like it's the fastest. Okay. All right, so moving on. How do we apply this to algebraic rational expressions? Well, rewrite the problem as multiplication if needed. So the first thing you want to do is, if the problem is a division problem, then you want to rewrite it as a multiplication. So we're like immediately just going to deal with the division and turn it into multiplication. Factor everything completely. Check out my factoring refresher video. I will try to link that right here. Before I did the last lesson, which was 3 weeks ago. It's been a thing. I've been out of town and I haven't felt well, and then school is starting. So I start school in 2 days as of the recording of this video. So yeah, I've been kind of busy. But if you want to review like just a factoring refresher, I will link that right there. Cancel factors common to the numerator and denominator. And again, I would cancel before I did any kind of multiplication. Just find anything in the numerator, can cancel with anything in the denominator, and it's all good. And then rewrite it as a single rational expression. In other words, then multiply. So you're going to multiply it together and it's going to become one rational expression. It's my cat again. She is hungry is what the problem is. So we're going to start with this division problem. And as we go through this, I am going to try to show you some ways that I reason these out, because I am not like a huge fan of doing tons and tons of factoring. So I look at this and I'm thinking, like, that's a lot. That's like a lot of negatives for one. I don't know what I was thinking writing this problem, but it's a lot of negatives. I see some leading coefficients, like stuff that, yeah. So first thing we're going to do is take that division and we're going to rewrite this problem as a multiplication problem. So 2x squared minus x minus 15 over x squared minus x minus 6. And then it's going to become multiplication by the reciprocal. So we are going to flip that second one over. So now we've done the division part, like we can just focus on the multiplication. Now what I typically do is I'm going to look at this, and I've got 4 factoring problems to do there. I am going to start with whatever looks like the easiest one. Okay, like that's all it is. And in this particular one, like I think the lower left looks like it's going to be the easiest one to factor. So let's do some scratch work. We have x squared, we have negative 6. We do a times c, so that gives me 1 times negative 6 is negative 6, and I need factors of 6 that add up to negative 1. My factor pair options are 1 and 6 and 2 and 3. 2 and 3 is the pair that will give me a negative 1, but only if the 3 is negative. So we'll have 2x and negative 3x. X times x is x squared. That's a 2, that's a negative 3. Double check everything, make sure all the boxes multiply. They do. And so this factors into x plus 2, x minus 3. Okay. Where do we want to go from here? I am going to, I'm going to go up here. So I think the next one I'm going to factor is this. And basically what I'm trying to do there is I'm trying to avoid the leading coefficients. I'm like just not wanting to deal with them. So let's go ahead and set this up. Now, I have a couple things I can do here. Here's what I'm expecting. Because of the type of problem that this is, I am expecting to see an x plus 2 in the numerator to cancel it out, or maybe an x minus 3. Now, not everything usually cancels out in these problems, so I'm not 100% sure of that, but there are ways I might be able to leverage that. So let's go ahead and do that upper right. So I have 1 times negative 12 is negative 12, and I want 2 factors of negative 12 that add up to negative 4. So my factor pair options are 1 times 12, 2 times 6, and 3 times 4. That's the pair that can get me a negative 4 only if the 6 is negative. So I'm going to have a positive 2x and a negative 6x. X times x gives me x squared. That's 2x, double check that. That looks pretty good. And so I have x plus 2 and x minus 6. Okay. So I feel pretty good about that. My x plus 2's cancel. Now, just leveraging stuff. Here's, because I've been avoiding the leading coefficients. I really don't want to have to factor those if I can help it. So here's what I'm going to do. I'm going to come down here. We're going to do the lower right. I am looking at my existing factors and I'm looking at the numbers that I have to play with. And I see an x minus 6. And I kind of think there might be a decent chance that that x minus 6 is going to turn up in the denominator. Do I know that for certain? No, not at all. I do not know this for certain, but it might be nice. So let's see what happens. I'm going to try to factor that lower right. I'm going to put the 2x squared and the negative 18. And here's what I'm going to do. I'm literally going to put in the x minus 6. I'm going to just assume for a second that one of the factors is an x minus 6. This may or may not work. I'm crossing my fingers. We're hoping it works. And then I'm going to do this by multiplication instead of by factoring. So x times 2x would give me 2x squared. 2x times negative 6 would give me negative 12x. Negative 6 times positive 3 would give me the negative 18. And then x times 3 would give me 3x. Now, before I can launch in anywhere and be like, here's what it is, I have to check and make sure this actually gives me the thing that I was trying to factor. So here's how we check it. 2x squared, 2x squared. Negative 12x plus 3x. Negative 12 plus 3 is negative 9. So this would be negative 9x. Yes, that is negative 9x. Negative 18, negative 18. And so you've got to do that check because what I just did there is not guaranteed to work. It's like noticing something and being kind of slick and saying, I think this would be a factor. And so I got the x minus 6. It turns out the other factor is 2x plus 3. All right, so let's come over here. And I could try to play that game again with like the 2x plus 3. I don't think it works in this one. So we're going to look at the 2x squared and the negative 15. So what I'm expecting to have happen, and if I want to kind of move ahead with the problem, I'm going to cross cancel. So I've got like an x plus 2, an x plus 2, an x minus 6, and x minus 6. So here's what I got to play with. I've got an x minus 3 and a 2x plus 3. I think one of those is probably turning up in one of these factors. Like I'm just expecting one of these to cancel out. Which one is it? I can't tell right off the bat because that 15 can produce the 3 for me and the 2 can come from here. So there's nothing like super obvious. So if you wanted to play that game, you could pick one of them and say, well, let's try the x minus 3. Let's just see. So that would make this 2x. That would make this negative 6x. This would be a positive 5. And this would be 5x. And then we have to check. Okay, 2x squared, yep. Negative 6x plus 5x is negative 1x. So it worked, negative 15, negative 15. So I picked the right one. So my factors are x minus 3, and it's a 2x plus 5. But it would not have been some big stretch for it to have been the 2x plus 3. And now I see I do have one more thing that cancels out. The x minus 3's. And so the last step is to rewrite that as a single fraction. So it'll be 2x plus 5 over 2x plus 3. And now you can see why in the practice set we only have 4 problems to do. And the third one has a typo. Heads up, third one has a typo. But you can see that took me like about 8 minutes with a lot of explanation. You might be able to do it faster on your own, or maybe not. It might take you like 10 minutes. So 4 homework problems or practice problems could conceivably be like a 40-minute assignment, depending on how fast you go. All right, let's look at example 2. This one is a multiplication one, and it does look a little bit different. So we have a 5 here. We also have a difference of cubes. So this is our soap sandwich. So when we go to factor that, that factors into the little parenthesis and the big parenthesis, and we do same, opposite, always positive. And we ask ourselves, what to the third power gives me 8? That's a 2. What to the third power gives me x cubed? That's x. And what to the third power gives me 27? That's a 3. And then the other one is square it, smush it together. I'm clapping my hands here. Square it, smush it together. And so our our slices of bread are 2x squared, which is 2x times 2x, or 4x squared. And then 3 squared, which is 9. And then we do 2x times 3 to get 6x. Ta-da. No, we want to be very observant here. We do not want to do extra work. Rather than setting this up and just being like going into autopilot, like, here's my parentheses. I'm just going into autopilot and I'm not paying attention to what's happening in the problem. Notice what's happening. 4x squared plus 6x plus 9, 4x squared plus 6x plus 9. I do not have to do that. Okay, and this is a good example of like a factor that's a trinomial. We think of factors as being these like binomials, but you can have a trinomial common factor as well. Then we have the 5, and then I'm gonna play that little trick that I did on the last slide, because I don't want to factor 6x squared minus 7x minus 3. I just don't want to do it. So 6x squared, and then this will be the negative 3. Here's what I think is going to happen. I think one of those factors might be a 2x minus 3. Do I know that for certain? No. Could I end up like getting partway through this and saying, nope, that didn't work. I've got to grind out the rest of the factors on this. Yeah, but let's see if it works. So 2x minus 3, 2x times 3x would give me the 6x squared. 3x times negative 3 is negative 9x. Negative 3 times 1 would give me the negative 3, and 2x times 1 is 2x, and then we have to check. So 6x squared, 6x squared. Negative 9x plus 2x is negative 7x. Yes, -3 checks. So I got a little lucky there. 2x minus 3, and then the other factor is 3x plus 1. So I got a little bit lucky there. I didn't know that that was going to work, but that is something I do. And that's the kind of thing that when you do enough of these, you just start to recognize what kinds of problems you're dealing with, like the patterns that happen. And you're sitting in class and you're wondering, how did that person get there so fast? Well, it's possible that they're not working all the factoring problems out like straight beginning to end, and that they're not using AI either. They're just saying, I'm just going to kind of take a guess and I'm going to work the problem backwards. All right, so let's go cancel out some stuff. I can cancel out the 2x minus 3's, and then that entire factor cancels with that entire factor, and I am left with 5 over 3x plus 1. So that one was a little bit faster to do. Again, they're not all the same. They're not all the same like level or time consuming, and you might get lucky, you might get really unlucky in doing a particular problem. Are they kind of pain in the neck problems to do? Yeah, they kind of are, and they involve a lot of factoring. So be patient with yourself doing them. The good news is that you probably in the course of your mathematical career are not going to see tons and tons and tons of these problems. They don't have like wildly common applications. You're not likely to see them in like a science class or anything like that. So if you're hoping to be a scientist or an engineer and you're getting to this in your math thinking, oh no, if I can't do this, I can never be an engineer. No, like it's not that common. So be encouraged with that. All right, so that brings us to the don't forget to slide. Don't forget to like this video if you found it helpful. Please subscribe to the channel for more math help. Like you get notifications whenever I upload. Ask a question to engage, and then check out the practice set linked below. And remember that there is a typo on number 3. If you want to do the third problem out like the way that it's intended to be done out, there is a -15 in the problem. It's a polynomial. It's like 5x squared minus 14x minus 15, and it should not be a -15. It should be a -3. So if you want to do the problem out, you want to do that, or you can do it out as it is written in the practice set, and that's the one that I'll go over in the practice set video. So doing my best to heads up, and then at some point maybe I will re-record it, although now I've tied this video to it, so who knows. Right now I got the start of school to deal with, so I've got like 160 70 kids, I don't know, coming my way Monday morning, and I don't know who they are yet. So one thing at a time. Anyway, I hope to see you in a future video, and I hope this lesson was helpful for you.